All right. Hello. We're going to do a quick video of some sample problems on IXL on finding the missing sides, which goes under the topic of similar figures, where we have things that are enlarged or shrunk, and we are told they are similar to each other. Symbol for that is the squiggly. It's called the tilde. I don't know how to pronounce it. T-I-L-D-E. Spanish or French or Latin, not sure. And if they're similar, it means they're proportional to each other. Like a map is not actual size. It's shrunk so we could see where everything is in the world, okay? Or a toy car, replica car, but then they have an exact duplicate that they build at the manufacturing factory or whatever. Okay, so you have many things in life where you have a picture of a sandwich at a store, and then you get it and it's bigger than the picture, but it's proportional. You can see approximate relationships. And the whole thing about the word proportional, we learned talking about ratios, rates, unit rates. Proportional means they have a relationship. So they increase in size together at the same rate. We jokingly call it the rate-lationship. Okay, so here's one example. We have sides that you can tell go together. We have the short left side. So those obviously are related. We call that corresponding, okay? Those are corresponding sides or matching sides. They go together. Let me change color. I guess I'll do the highlighter. The long bottom obviously goes with the long bottom of this one, okay? So once we know which ones are corresponding or related, we can set up a fraction. Rates are fractions. You guys see rates every day when you get in the car with your parents. They're called speed limit signs because they say how many miles per hour. Now it's only per 1 hour, 60 miles per 1 hour. So that's a unit rate, but it's miles over hours. So it's a relationship between how far you travel distance and what amount of time. That's a rate. So I can look at these two shapes and I can make a fraction and say 4 over 2, because those can go together, has the same relationship as the bottom 10 over x. Okay, so, and I can look and say, well, sometimes we try to go this way. Does 4 go into 10? No. Now I could reduce or simplify this 4 over 2 right here to be 2 over 1, and I could say 2 goes into 10 5 times. Where we do the top, you got to do the bottom. Other times you may see the relationship in the fraction itself. I can see that 2 is half of 4, or the top is twice what the bottom is. So if this bottom is half of the top, what does this have to be? It has to be half of the top. It has to have the same relationship. So it's got to be 5. You guys can kind of logically deduce this and understand it without exactly knowing why, okay? But that is the why. We set up a proportional relationship or rate relationship. Now, honestly, too, you could have set the fraction up with 4 over 10. Oops. Let me go to red here. You could have said 4 over 10. I honestly usually do it this way. I keep the same triangle together in a fraction. That's usually what I do, okay? And I could say 4 over 10 is the same thing as 2 over what? Okay. And I can see that 2 is half of 4. So this one is going to have to be half. So I know it's going to be 5. Okay. So x equals 5. All right. I'm just going to do a few questions to show you the IXLs. And we will. Hello, everybody. All right, so this is IXL X17 for 7th grade. It had already been starred and assigned. Side lengths and angle measurements. It's really not going to talk about angle measurements. Well, they have a question mark there. Oh, they did ask that. Okay. And when I did this last night, it didn't once ask me an angle measurement. The one thing you can know is that the angle measurements are going to be the same, okay? Whether you shrink it or enlarge it, if you measure that angle, it's going to be the same. The only thing is, we learned in class yesterday, sometimes they will rotate it, okay? And you have to say, oh, well, this angle would be the same as this angle. You can see that they rotated it, okay? So on some of these problems, you're going to have to spin it, but this angle is going to be the same as that angle, okay? They will be the same degrees. You're just shrinking it or enlarging it. Okay, that looks really messy, but just while I was explaining, it helps you know what I'm talking about. So we're going to have 115 and 115 on the top. This bottom one is going to be 65 degrees, okay? So those are, if you get angles, that's the easiest one. It's going to be the exact same as the other angle, okay? So here they're doing it again, and it's missing side lengths and angle measurements. I'm hoping you guys get more practice at missing side lengths because that's where we have to do the proportions. But I can see if they tell me they're similar, they're telling me that. And again, this is the little symbol for similar. This shape is similar to this shape, okay? Then I know these angles have to be the exact same. Let me switch back. I'll hit 75. I'm going to keep doing on this level until they give me some missing side lengths, okay? Man, last night it gave me all side lengths. Now they're giving me all angles. So now I can see, I can even see. I wanted to tell you one thing though, guys. Don't ever look at this shape and say to yourself, oh, okay, those look like 90-degree angles. Don't ever do that because sometimes it's just the picture a teacher copied and pasted and it may not be exactly what they were trying to show. You have to, they said it was similar and you have to go to this one and find out what it is, okay? And it is 90, but I'm just reminding you guys, sometimes the pictures lie. Don't go by the pictures, go by the numbers the math teacher gave you, okay? So that should be the exact same angle, 90 degrees, terrific. Wow. Now I'm going to hit refresh and see if it, if I hit refresh, it starts me over back to 0. Here we go, missing sides. That's a little better. That's what we really wanted to cover. The missing angles are easy. All right, so these two shapes are similar. Now the first thing I got to do is see, we learned 3 vocabulary words: reflection, rotation, and translation. Translation, it's exactly the same orientation. This side is on the bottom over here. This angle would be on the left side, this angle would be on the right side. They just slid it somewhere on the screen. It's the same everything. But this one, you can tell it's actually rotated just a little bit. Here's the pointer right here. Oh, I lost my little, don't leave me, guys. Here's the pointer. They just spun it up 1. So now the pointer is going up. Okay, so you just want to do that so you have some kind of way to tell which sides go together. So I know this 12 and 2 go together, and I know this 6 and Q go together. And just apologize for one moment. One of the things we tried to do as teachers, just so everybody can see what we see. As teachers, just talk and keep going. Green on green is not really going to show up, is it? But let me just make some color. So now you can see it. Now we're going to rewrite this, okay? 6 over 12. 6 is the yellow. Oh, and one other thing I saw teachers online do, that's supposed to be an equal sign. They would make the same numbers the same color. Now, I'll go ahead and change back to a purpley kind of color. So they would make the 12 that color and the 2 that color. So you can physically see the colors and where they're coming from, all right? So then all you got to do is figure out what happened. You guys knew the answer long ago. The Q is going to be half of the bottom because this is half, okay? Or you could say this is divided by 6. So I'm going to divide the top by 6, okay? Or you can do it the other way, whichever way you see a relationship. So that's got to be 1. And you're going to see, even as I skip ahead, correct? Good job. I'll do one more at this level, then I'll go to the next level. And see, look, it's giving me all, I don't know why it does that. It's giving me all lengths again. These two shapes are similar. What is the measure of the missing Z? Okay, so we'll go the long side, oops. The long side will be the Z, and then I'll go blue for the bottom. Oops, didn't do it. blue, blue, and I've covered the number, but I know it's a 2. Okay, so I'm going to end up with Z. Oh, Z was supposed to changing colors. I actually did it last night without speaking, and I did everything perfect. So if I'm going purple, I want Z is to 8, and then I'll change to blue. And Z is in the same triangle as this one, or the same parallelogram. So what you can see is it reduced by half. Okay, so then you can say what's half of 8. Okay, so half of 8 is going to be 4. Ring. Total brill, yo. All right, let's just wipe that. Let's go to next level, and you're going to see they're pretty much exactly the same. Well, I'll keep doing this level till they give me a missing sides, hopefully. Or maybe this is what they're going to do, this whole thing. All right, so as long as you can see, the angles are slightly different. One is more open than 90 degrees, and one is more pointy, less than 90 degrees. So this is just translated, translational. We jokingly call it transported. They just moved it. They didn't spin it or flip it. So this is going to have to be the same. The 119 is the bigger degrees, and the smaller one's going to be 61. So like I said, if you get those are going to be your easier ones. More angles. Well, I might just have to skip to go. Okay, so this one's a little bit trickier. So we got to double check. It is spun a little bit. Okay, so you could basically see that this pointer right here, this is more than 90 degrees, okay? This little pointer has been spun down, okay? So that 71 degrees is on both sides. That's going to be the same here, 71, 71. Super easy, right? That's not what I want to prepare you for. Our test Thursday isn't really going to mess with the angles. That's why I want to see these missing sides. Here we go. After I do this missing side, we'll go to the next level. And the next level goes to the challenge level, because this is all it is, guys. Okay, well, geez, which side's the short side, which side's the long side? So we'll do blue down here, and we'll go purple again, purpley, pinky, whatever. And whichever, it's just the length, it's a little off. So with that color, I could have T, and then I could have 80 over here. And the way some teachers do it is they do the, I couldn't even do that right. They would do the fraction bars and the equal sign a different color, and then we'll go to blue. And the T goes with the 7. You got to make sure, I don't want to put under the T the 80, or the T's across from the 8. I don't want to put the 8 below it, because it has no relation to that. I can say it's related to the 80 because they're both right sides. And I can say it's related to the 7 because they're in the same family, the same shape. So T is to 80 as 7 is to 8. So as you can see, it didn't change much, okay? So the next thing we want to do, and I've seen so many teachers online, guys, you wouldn't believe how many videos I watched last night to give you the right ones to watch this morning to see the easiest way to do it, explained correctly with the vocabulary and everything. But so many teachers right here would say, cross multiply and then divide, okay? That's all well and good, but what do I always say? I think I have a few witnesses nearby. Does anybody know what I always say? If you have fractions, what do you do to make life simpler? Simplify. Always try to simplify. I got 80 over 8. So I can divide that by 8. If I divide and simplify the top and the bottom by 8, I'm going to get 10 over 1. Okay? So now what I'm really saying is T, I just can't get these colors down, how to switch them. What I really have then is T over 7 equals 10 over 1. How did we get from 1 to 7? Make sure I'm going to do red. How did we get from 1 to 7? Times 7. How do we get from whatever you do to the bottom, you got to do the top. So I'm going to have 70. And doesn't that make sense? 7 is to 8 as 70 is to 80. That makes total sense, right? Okay, so 70. Did I do it right? 7 times 10, 7. Yeah, okay, I kind of got lost in thoughts there. Okay, let's skip a level and see a challenge problem. You guys are good to go. This is really easy stuff. As long as it's not angles, I'll keep doing it until they give me a challenge level. Here we go. That's what I wanted. So at the challenge level, you might actually have to do cross multiply and divide. We'll see. But when I see 22 and 33, I'm like, hey, they're probably going to let me simplify by 11. We'll see. We'll see. All right. So first, I've got to match my sides. They didn't rotate it or flip it or anything. So I can just go ahead and see that this long side goes with that long side. And I can see that this little short side goes with this little short side. So I will put X. That's not an X. I don't know what I was drawing. I tend to think ahead while I'm writing, and a lot of times, so it's funny is in class a lot of times, I would physically start to write the answer because I'm thinking ahead instead of the problem. And then I'm like, I just gave you the answer. Silly teacher. All right, so let's go back to red. So X is in this shape right here. So I'm going to put the 33 with the X. The 6 is with the 22. Okay. So the first thing I want to do, I see a fraction. Whenever we see fractions, we want to try to simplify. So I can divide, 6 doesn't go into 22, 3 doesn't go into 22, but I can divide them both by 2. So we will start with that. And then that's, I told you I saw that relationship of an 11. So this is going to give me 3 over 11. And if I didn't want to rewrite it or anything, I could just go and say, now, how do I get from 11 to 33 times 3? So whatever you do to the bottom, you got to do to the top. So 3 times 3, X is going to equal 9er. 9er. And that's going to be it, guys. Drum roll. Boom. Great job. All right, guys. That is it. Good luck. And I got to go find out the end of the video. Have a great day. Good luck with your homework. Shoot me any questions if you need help. Ta-ta.